Okay, so now we have to use a subset construction algorithm to build a DFA that recognizes the same language as this one. Okay, so I write the starting state, and then I have to explore under every possible character, where could it go? So let's start with 0. So if I'm in S0 and I read a 0, I could go back to S0, or I could go to S1. So I'm going to represent that with a new state, S01. You might see in lectures or other sources they like to write it as a set of states. You can do that, but the naming of states is totally arbitrary, so I like to write it in this compact form just because it's faster to write down. Okay, so if I'm in S0 and I read a 1, I can only go to S1. Cool? So now I have to explore all the reachable states. I haven't explored S01, so I guess I'll do that first. So if I'm in S01, that basically means if I'm in S0 or if I'm in S1. So if I'm in S0 and I read a 0, I could go to S0 or S1. So it's at least that. And if I'm in S1 and I read a 0, I can't go nowhere. So it's just S01. Okay, let's look at the next one. If I'm in S0 and I read a 1, I go to S1. And if I'm in S1 and I read a 1, I go to S2. So I can go to S1 or S2, which I'm going to write as S12. Okay, so what states are reachable that I haven't explored? I haven't explored S1, I haven't explored S12. So we're going to do both of those. So for S1, reading a 0, I can't go anywhere. So I go to the empty state, or the state that represents being in the set of no states. And from S1, reading a 1, I can go to S2. So now I got to explore S12. If I'm in S1, reading a 0, can't go nowhere. If I'm in S2, reading a 0, I can go to S1. If I'm in S1, reading a 1, I can go to S2. If I'm in S2, reading a 1, I can go to S2. So the place I can go is only S2. So what haven't we explored? Haven't explored S2. S2 under a 0 goes to S1. S2 under a 1 goes to itself. Is that all of them? Yep, with the exception of the null state, but the null state's easy because if you're nowhere, you unsurprisingly can't go anywhere. Okay, so now we have identified the starting state, which is S0, and the final states, which is anything containing a final state, so anything with a 2 in it. Okay, and then from this table, I can then draw the transition diagram, so I'll do that for you, which looks like that. Note that there's technically no reason for me to have to draw out this transition diagram. The question says, use the subset construction algorithm to produce a deterministic finite state automaton. Technically, this table alone is a valid description of a DFA. So if you're pressed for time in the exam, you could just draw this table and not even bother to draw this thing, and it would still be a totally correct answer because everything that this diagram encodes, this table also encodes. You just have to make sure you indicate which is the starting state and which are the final states, and this would also be a valid answer.